Skipping over 5.5, moving to 5.6, we are going to be graphing linear inequalities in two variables today. You guys remember inequalities? Anybody? Anyone tell me what an inequality is? Or what symbols we use? Anyone tell me what an inequality is? Or what the symbols look like or are called? Yeah, greater than, less than, greater than or equal to, less than or equal to. Everyone remember those symbols or no? Hopefully you do. Today we're going to be dealing with inequalities that have two variables within the inequality. And we're going to be graphing them on our coordinate plane instead of just on a number line like we've been doing. Okay? So a linear inequality in two variables, x and y, can be written as one of the following. Depending on what your inequality symbol is, the left side of the inequality will be ax plus by. The right side of the inequality will be c, which will be a constant. And then you can have less than or equal to, greater than or equal to. Where a, b, and c are real numbers, very similarly to a solution of an equation, a solution of a linear inequality in two variables is an ordered pair that makes the inequality true. So, for an ordered pair to be a solution of my inequality, I have to be able to plug it in for x and y, and it comes out as a true statement. Okay? Does everyone understand that? Just like for an ordered pair to be a solution of an equation, I've got to be able to plug it in the equation, and it's got to come out to be a true statement. Are there any questions on what an inequality is in two variables, or what a solution of a linear inequality is? I'm assuming we're still writing? Okay, I'll give you a little more time. We can write our inequalities in kind of a slope-intercept form, where y is by itself on the left side. We have our x term on the right with our constant. We will have to do that sum in order to graph our inequalities. But it's very similar to equations. Does anyone remember what we have to do if we multiply or divide both sides of an inequality by a negative? Yeah, you got to flip the inequality symbol. That's still going to apply today. If you're solving your inequality for y, and you multiply or divide both sides of the inequality by a negative number, then you've got to flip your inequality symbol either from less than to greater than or greater than to less than. Okay? So always keep that in mind. Can I go ahead and move on? All right, example 1. Tell whether the ordered pair is a solution of the inequality or not. So letter A, it gives us the inequality 2x plus y is less than negative 3. It's wanting us to tell whether the ordered pair, negative 1 comma 9, is a solution of our inequality or not. So how are we going to do this? How are we going to tell if negative 1 comma 9 is a solution of 2x plus y is less than negative 3? Yeah, what's my x value here? Negative 1. What's my y value? 9. I'm going to take the x out, put negative 1 in its place, take the y out, put 9 in its place, and then work down both sides of my inequality. So 2 times negative 1, because that was times x, plus 9 is less than negative 3. Is there any confusion on where I've placed my values? Negative 1 is my x value, so it goes in for x. 9 is my y value, so it goes in for y. Now, I'm not moving anything from one side of the inequality to the other. I'm just working down the left side and the right side. So on the left side, what do I need to do first? Yeah, 2 times negative 1, which gives me negative 2. I still have plus 9 is less than negative 3. Now what's negative 2 plus 9? 7 is less than negative 3. Can I work down the left side anymore? No, it's just down to one singular number. Can I work down the right side at all? Nope, it's one singular number. So I'm down to my statement that I'm looking at. 7 is less than negative 3. Is that true or false? False. 7 is not less than negative 3. So what would you say about negative 1 comma 9? Negative 1, 9 is not a solution. Now, if you get a question like this on your assignment, which you most likely will, do not put no solution. This inequality does have a solution. It's just not negative 1 comma 9. Does that make sense? So don't put no solution. We're just saying that this specific ordered pair is not a solution. Questions about that? You okay with that concept? Okay, letter B. Gives us the inequality x minus 3y is greater than or equal to 8. And wants us to tell if 2 comma negative 2 is a solution to that inequality. Same concept as letter A, right? Plugging in values for x and y and working it down. What's my x value here? 2. What's my y value? Negative 2. So take x out, put 2 in its place. Minus 3 times y, which is our negative 2, is greater than or equal to 8. Now working down both sides. What's negative 3 times negative 2? Positive 6. So 2 plus 6 is greater than or equal to 8. What's 2 plus 6? 8 is greater than or equal to 8. Can I work down in any more either side of the inequality? No. So this is a statement I'm looking at. 8 is greater than or equal to 8. True or false? True. If it's a greater than or equal to, it has to just meet the greater than or it has to meet the equal to. It does not have to meet both of them, right? So 8's not greater than 8, but it is equal to 8. So this is a true statement. So what would you say about 2 negative 2? 2 negative 2 is a solution. Any questions about testing an ordered pair to see if it's a solution of our inequalities or not? You're okay with that? Kind of same thing we've been doing, right? See if something's a solution, plug it in. True statement, it is a solution. False statement, not a solution. Yes? Sometimes you will, and we're just about to get into the bulk of what we're going to be talking about today. This is just to make sure you know how to plug in and check that whatever solutions you get are actual solutions. Does that make sense? So, any other questions on example 1? Okay, let's move on. Okay, we're going to be graphing today. We're going to be graphing our linear inequalities. The graph of a linear inequality in 2 variables shows all the solutions of the inequality in a coordinate plane. So, like I just said, the graph of a linear inequality in 2 variables shows all the solutions of the inequality in a coordinate plane. For a linear inequality, we have an infinite number of solutions, so we use a graph to represent all of them because it'd be impossible for us to list every single one. Okay? So, the inequality we have here in this example is y is less than 2x. So, the boundary line is called a boundary line. It's created by replacing our inequality symbol with an equal sign. Does everyone understand that? So we're graphing y equals 2x. What's the y-intercept for y equals 2x? If I have y equals 2x, what's my y-intercept? 0. So our starting point is 0. Slope is 2 over 1. up 2, right 1, up 2, right 1, down 2, left 1. Does everyone see how we got this boundary line? The boundary line divides the coordinate plane into what we call two half planes. The shaded half plane is the graph of y is less than 2x. The shaded regions representing all of our solutions of that inequality. Does that make sense? So if an ordered pair falls in that shaded region, it's a solution of this inequality. Everyone okay with that? What do we notice about our boundary line here? Is it like a normal line that we've drawn before? What's different about it? Yeah, it's a dotted line. It's sometimes called a dashed line. Does everyone notice that? It's not just a solid line. Anyone want to take a stab at why that's the case for this specific inequality?
Is it because it's split in half?
Not quite, because sometimes it will be a solid line. Sometimes it'll be this dashed or dotted line.
Not all the spaces in between.
Kind of. So here, think back to whenever you graphed inequalities on a number line. Think about open circle, closed circle. What determined if it was open or closed? Yeah, if it had the line under it, it was a closed circle, right? If it didn't have a line under it, it was an open circle. You guys remember that? Does this inequality symbol have a line under it? Is it or equal to? No. So if there's no line underneath your symbol, it's a dashed or dotted line. If there is a line under it, if it's or equal to, it's going to be a solid line. Does that make sense? Okay. Any questions on this slide right here? The shaded region, the shaded half plane, represents all my solutions of y is less than 2x. Okay? We okay with that concept? Write these steps down. Steps for graphing a linear inequality in two variables. Step 1, graph the boundary line for the inequality. So it's just going to be like using slope and y-intercept to get our points, our ordered pairs. Graph your y-intercept first. Use your slope to get more points. Use a dashed, if you want to use the word dotted, you can. Use a dashed line for less than or greater than. Notice they don't have the bar under them. Use a solid line for less than or equal to or greater than or equal to. It has the line under them. So line underneath, solid line. No line underneath, dashed line. Step 1 is just graphing the boundary line. These are the steps from the book that I gave you. So I'll show you both ways, but I'm going to show you this way, and then I've got another way that I like to do to shade our graphs. But this is how the book teaches it. Step 2, test a point that is not on the boundary line to determine whether it is a solution of the inequality. So pretty much just doing what we did in example 1. Pick an ordered pair that's not on your boundary line. A good ordered pair I always like to use if I'm testing an ordered pair is 0, 0. That's really easy to plug in if it's not on our boundary line. Just think of easy ordered pairs to plug in. 1, 1, 2, 2. Don't pick some big number like 100, 250. That'd be really hard to plug in. So test a point that is not on the boundary line to determine whether it is a solution of the inequality. Step 3. If you plug your test point in and it is a solution, shade the half plane that contains that point. That means that all ordered pairs on that side of the boundary line are also solutions to your inequality. Excuse me. If you plug it in and the test point is not a solution, shade the half plane that does not contain the point. You know that, hey, this ordered pair is not working, so it's got to be the other half plane that I need to shade. Does that make sense? After you do that, after you've shaded your graph, you've got the representation of all your ordered pairs that are solutions. Okay? So like I said, I've got another way of shading that I will show you after we do our example. So pick a test point not on the line. If the test point is a solution, shade that half plane that contains the ordered pair. If it's not a solution, shade the half plane that's on the other side of the line that does not contain that ordered pair. Can I move on, or are we still writing? Okay, I'll give you some more time. Like I said, make it easy on yourself and pick an ordered pair that's really easy to plug in. If 0, 0 is not on the line, it's probably one of the easiest things to plug in. These steps are in your textbook. If you don't get them all written down, I'll also post these notes to Canvas. So if you do not get them, you can get them from either your book, a friend, or the notes on Canvas. But I am going to go ahead and move on to our next slide. Example 2. Graph y is less than or equal to 2 in a coordinate plane. Y is less than or equal to 2. So right off the bat, we got one of our special lines here. Step 1 tells me to do what? Yeah, I'm going to graph y equals 2. That's going to be my boundary line. I just replace the inequality with my equal sign, right? How do I graph y equals 2? Yeah, this is Hoy, right? Golly. It's just y equals a number. So I know it's crossing which axis? The y-axis where? At 2. So put a point at 2 on your y-axis. What does the H on Hoy stand for? Horizontal. So I'm going to draw a horizontal line through this 2 on my y-axis. But before we draw our line, we've got to determine if it's dashed or solid. So look at the inequality symbol. It's got a line under it. If it has a line under it, is it dashed or solid? Solid. So it'd be a solid horizontal line going through that point. There's my boundary line for my graph. Any questions about that? How I got that? Okay, step 2, what does that tell me to do? Test a point that's not on my boundary line. What point do you guys want to use? Huh? I heard 0, 0 first. It's always a good one to plug in. It's probably one of the easiest to plug in. So let's test 0, 0. Plug it into our inequality. What am I plugging in for x? 0. What am I plugging in for y? 0. Do I have an x? Nope. So I'm just going to plug in 0 for y. 0 is less than or equal to 2. There's nothing to work out. Everything's already worked down to one number. So 0 is less than or equal to 2. True or false? True. So step 3 tells me when the test point is a solution. So our test point is a solution in this case, correct? So when it is a solution, shade the half plane that contains the test point. So I'm going to shade this half plane that contains 0, 0. You don't have to shade in every single square. Just make sure you shade it all so I know which side you're shading. I'm now done with the problem. There's my graph of y is less than or equal to 2. How do we feel about that? Maybe a little better with more practice, hopefully? Okay. Any questions on that? Let's say I picked a different ordered pair. Let's say I picked 3, 3. It's on the other side of the line, isn't it? Let's say I picked 3, 3. You only have to pick one test point. I'm just showing you what would have happened if I picked a point on the other side of the line. I'd plug 3 in for y, nothing in for x, right? 3 is less than or equal to 2. Is that true or false? False. If you plug in a test point and it's not a solution, shade the half plane that does not contain the point. So we still would have been shading this side because I'd be shading the half region that does not contain 3, 3. Does that make sense? Any questions about that? So, let me tell you about the method that I like to use to shade. You can use this method if it works for you, if you're more comfortable with that. But what does my inequality say? Y is less than or equal to 2. Well, I just told you. It's less than, right? So, less than means I'm shading below the line. And that's it. Does that make sense? Okay. If it was greater than, I'd be shading above the line. Pretty easy, right?
What if it was bucks?
That's a very good question. I'm glad you brought that up. Any questions on y is less than or equal to 2? Let me erase and give you a Vux problem here. I was actually wanting to do this. Say I gave you x is greater than 4. X is greater than 4. Like we said, it's a Vux. It's crossing which axis? X-axis where? 4. Let's put a point at 4 on your x-axis. What does V stand for? Vertical. However, is it going to be a dashed or solid line? Dashed. There's no bar underneath my inequality symbol. So it's a dashed vertical line going through 4. Still want our arrows on the line because that line still goes on forever and ever and ever. So there's my boundary line. So if we're using my method to shade, x is greater than 4. Well, think about the x-axis like a number line here. If I want values that are greater than 4, would that be to the left or right of 4? What? To the right. It's also pointing to the right. So I'd be shading over here. This half plane. That makes sense? The test point still works here. So we pick 0, 0 again to test. I only have x in my inequality. What am I plugging in for x? So that's my x value. 0 greater than 4. True or false? False. So since it's not a solution, I want to shade the half region that does not contain 0, 0, or the half plane. So that'd still be this right here. Does that make sense? Questions on example 2? Let's move on. Graph negative x plus 2y is greater than 2 in a coordinate plane. Negative x plus 2y is greater than 2. What form do I want this in order to graph it? Not quite. That's the form that it's currently in, is what you were telling me, standard form. In order to easily graph it with a slope and a y-intercept, what form do I want it in? Huh? We forgot what it's called? Slope, intercept, form. Right? Y equals mx plus b. So, we got to solve this inequality for y. What would be my first step to do that?
Get x.
Add x to both sides. Can I combine 2 plus x? No. So I'm going to write it out as x plus 2. Did I multiply or divide both sides by a negative? No. So does my symbol flip or stay? Stay. Last step to get y by itself. Divide everything by 2. X over 2 is just 1/2 x. What's 2 divided by 2? 1. Symbol flip or stay? Stay. So there's my equation, my inequality, solved for y, slope-intercept form. Y is greater than 1/2 x plus 1. So, step 1, graph your boundary line. What's my y-intercept here? 1. So put a point at 1 on your y-axis. My slope? 1/2. So which two directions, how many units? Up 1, right 2 from your y-intercept. Or down 1, left 2. Is this going to be a solid or dashed line? Dashed. Why dashed? Yeah, it's not or equals to. There's no line underneath my symbol. So it's going to be a dashed line. Everyone okay with that? Still graphing our normal lines like we've been doing. We just have to tell whether it's going to be solid or dashed. You do need your shaded region as well. So, if we're using my method, y is greater than 1/2 x plus 1. Would greater than be above or below the line? Above, so I'd be shading up here. Does that make sense? You can still use the test point. What test point would you want to use here? Yeah, I'd use 0, 0 all day long as I'm able to. It's not on my line, is it? So I can plug in 0 for y, 0 for x, and work down both sides of the inequality. What's 1/2 times 0? 0. What's 0 plus 1? 1. 0 is greater than 1. Is that true or false? Huh? That's false. 0 is not greater than 1. So I would want to shade the half plane that does not contain 0, 0. So that's above my line like we had already said. Any questions on that? Are we kind of feeling a little more comfortable with it, hopefully? Just really adding one more step than our normal lines. The shading, right? Can I move on? You can spend at most $10 on grapes and apples for a fruit salad. Grapes cost $2.50 per pound, and apples cost $1 per pound. Write and graph an inequality that represents the amount of grapes and apples you can buy. Identify and interpret two solutions of the inequality. So first, we've got to come up with our inequality based on all our information given. If we can spend at most $10 on grapes and apples for a fruit salad, can I spend more than $10? No. So what's my inequality symbol going to be? Less than or equal to. My amount has to be less than or equal to 10. Right?
Yeah.
So I can spend at most 10, no more. But I can spend less than 10 if I need to. Grapes cost $2.50 per pound and apples cost $1 per pound. Trying to find out how many pounds of grapes and apples we can buy, right? So that's probably what our variables are going to represent. X is going to be pounds of grapes. Y will be pounds of apples. So what would the left side of my inequality look like here? Does everyone agree with that? 2.5x plus y is less than or equal to 10. There's understood to be a 1 in front of that y. If you need to write it, go ahead and do it. So there's my inequality. Everyone agree with that? The price per pound of grapes times the amount of pounds of grapes I get, plus the price per pound of apples times the amount of apples I get. That's my total. Has to be less than or equal to $10. Everyone okay with how I got that? Wants us to graph it as well. So let's go ahead and solve this for y. What would be my one step to get y by itself here? Subtract 2.5x from both sides. Can I combine 10 minus 2.5x? They are not like terms, so I just got to write it out. Symbol, flip, or stay? Stay. I did not multiply or divide both sides by a negative. Keep that in mind when you're doing your assignment. And we're going to be graphing. So we want a fraction as our slope. So how would I make negative 2.5 a fraction? If you type negative 2.5 in your calculator and click enter, and then hit the two arrows above the enter key, it'll convert it to a fraction for you. Negative 5 over 2. So here's my inequality that it wants me to graph. Everyone okay with that? Less than or equal to negative 5 halves x plus 10. Yep. Let's graph it. What's my y-intercept? 10. Slope is negative 5 over 2. So which two directions, how many units? Down 5, right 2 from my y-intercept. 1, 2, 3, 4, 5, 1, 2. 1, 2, 3, 4, 5, 1, 2. Do I want to extend my graph past the x-axis? Why?
No.
Why not?
Because it's
What types of y values would these be?
negative.
Negative. Am I going to buy negative pounds of apples?
Yeah,
No. I'm just going to be buying 0 or positive pounds of apples and grapes, right? So I want to even extend it past my y-axis this way if I was able to. So I'm just going to stay in this first quadrant because that's positive and positive. Does that make sense? Is this a solid or dashed line? Solid. Golly, that's ugly. So there's my boundary line. Y is less than or equal to negative 5 halves x plus 10. Would that be above or below my line? Below. So that'd be this little triangle. Once again, I'm not shading past that because I only want positive values for my given scenario. So this would represent all my solutions to this inequality. So, there's my graph. Identify and interpret two solutions of the inequality. So what's one solution here that you could give me?
1, 4.
Yeah, 1, 4 is right here. That's in my shaded region. That means it's a solution, right? What does that mean in this case? If I have 1, 4?
That you can have 4 pounds of grapes and 1 pound of apples. You can have 1 pound of grapes and 4 pounds of apples.
Yeah, X represents the pounds of grapes, Y represents the pounds of apples. I could buy 1 pound of grapes, 4 pounds of apples, and still be under or at my spending limit for my fruit salad, right? What's another solution here?
2, 3.
Yeah, 2, 3. That's also in my shaded region. I could buy 2 pounds of grapes, 3 pounds of apples for less than or equal to $10 for my fruit salad. Does that make sense? One thing I failed to mention earlier that I want to mention to you guys. Do you guys remember what the open and closed circle meant with our number lines, when we graphed with our number lines? What did the closed circle mean?
That you can go up to that number.
Yeah, that number is included in my solution set, right?
Yeah.
What did the open circle mean?
That it did.
Yeah, that number that circle was on was not included. It goes up to that number, but that number itself is not included. Same concept for my solid versus dashed line. If it's a dashed line, the ordered pairs on that line are not a solution. The solutions go up to that line, but those ordered pairs on that line are not solutions. If it's a solid line, those ordered pairs are solutions. Does that make sense? Any questions for me? How are we feeling about graphing linear inequalities? Good? Good. All right. That was my last slide for you guys. We'll get our assignment tomorrow in class. Any questions about the notes before I end the recording?